Well, maybe you can see on the bench today I've got something a little bit different, which is a Lafayette HA-600A. And I say that it's a little bit different because this is actually a solid state. It's an old transistor set, none of those horrible integrated circuit affairs, but it's not actually valves, so that's a little bit of a departure for the stuff that I normally do. I do try to avoid transistors because it's a little bit too close to the day job, but we work on them if we have to. So when I first switched this radio on, I thought it was possibly working okay, but perhaps a little bit deaf. So I'm actually on the AM broadcast band at the moment, so let's have a quick tune through.
To get some sort of truth about the deaths of our loved ones.
So that's one station we've picked up.
He's not available. They're not going to risk him ahead of the cup final.
2 stations.
You on Absolute Radio. Choice of all the players.
3 stations. So really we can just pick up 3 stations, and if we actually go on the other bands we can really pretty much pick up nothing. That's 1.6 to 4.8 megs. Here's 4.8 megs to 14. And let's go 10.5 megs to 30. Just turn the volume up a bit more. Now we really can't hear anything. And then we've got 150 kilohertz to 400. And again, it's just totally deaf. So what's going on? Well, good question. I think the first thing we'll do is, although it does sound quite deaf, I don't think it's necessarily a good thing to do to listen to stations on the air, because you never know, it might just be a bad day reception wise. You do get bad days for reception, or could be some source of blocking interference that's stopping it working. Unlikely, but possible. So the first thing I would probably like to do is I'm just going to plug a signal generator in and actually just get a kind of a rough level to find out what it takes to light this setup. So let's go ahead and set this to, I don't know, approximately 1 megahertz. We'll go on the broadcast band and we'll connect up the signal generator and see how much signal we've got to put into this thing to make it chooch. So we've gone ahead and I've set up my old Marconi here to output a frequency of 1 megahertz, 80% AM modulation, and that's set to a 1 microvolt output. So back to my receiver here, I've turned the volume fully up, and yeah, absolutely not a sausage. Now this set gives a figure of something like 10 dBs for 1 microvolt input, so I would be expecting to hear something right now. I would certainly be expecting to hear some change in the background noise if I was to connect and disconnect the antenna which is connected to the signal generator, but we get nothing, not a sausage. So what I'm going to do is I'm going to go over to this signal generator now, having set this volume to maximum, and let's just increase the signal level until we can hear something. So let's go for 10 millivolts. Okay, absolutely nothing. Let's go for 50. Okay, 50 microvolts, absolutely nothing. Let's try 100 microvolts. Still nothing. 200 microvolts. Nothing. 300 microvolts. Okay, and I can just hear something now. I can hear something at 300 microvolts, but the S meter's not even moving. Let's go a bit more. 400 microvolts. Hopefully you can hear that. And finally, let's go to 500 microvolts. So basically we're having to put 500 microvolts into this radio to basically pick up any station, so certainly it appears very deaf. Let's just try one of the other bands. So just because I'm lazy, I'm just going to set this to 10 megahertz now. Okay, so we're at 500 microvolts, still got nothing. Let's try 600, 700, 800. Well, I'm hoping you can hear that. I've actually had to increase the voltage of the input now to actually pick something up, so I'm not in microvolts anymore, I'm now in millivolts. So I'm at 70 millivolts, so I can just about pick something up. So it is fair to say that this receiver is very, very deaf. Well, as you can see, I've gone ahead and I've turned the radio over, and it didn't really take a lot to get her out of her underwear, so we can see her bare beneath now. I've been taking a quick squint at what I think is probably one of the worst drawn circuit diagrams that I've ever seen. It's certainly not very easy to figure out what's going on. But basically, at the front end, there's an IF trap here, which is connected directly to the antenna connection. Then the signal comes in and it goes to what is effectively an RF gain control. It just goes to a potentiometer, and then it squirts it into what I think is an RF preamplifier, which is on this board down here. So take a look at the preamplifier here. I can see that it's got a field effect transistor, and effectively that field effect transistor is connected straight to the front end of the receiver. Now, if any of you have messed with these field effect transistors or receivers that employ them, you'll know that they are very, very easily damaged. I've certainly had some Yaesu transceivers in the past that had an RF FET at the front end, and they used to blow up fairly regular. Things that could blow them up would just be actually even just touching the antenna connector. If you'd have charged yourself up walking on the nylon carpet, you could touch these connections at the back, and you could have enough electrostatic charge there just to punch a hole through the gate of the FET and do a lot of damage. The other thing that would damage them, of course, if you have a nearby lightning strike, the actual voltage could be quite high enough to fry this front end. Now, I suspect that that's what's probably wrong with this. The other thing that I'm very suspicious of, it's got a mechanical filter in here. Now, mechanical filters in old pieces of radio equipment, to me, they cause no end of problems, and they can be very difficult, stroke impossible to repair, because you just can't get the replacement parts. Sometimes you can just short them out and effectively bypass them in the circuit, but usually it's a bit of a lost cause. So I'm hoping that the problem is located in this front end FET rather than in this mechanical filter later in the circuit. So because I do actually suspect that this FET at the front end is the problem, I think what we'll try and do is we'll just try and bypass that. So rather than introducing the signal directly at the antenna, we'll actually try and introduce it at a later point in the circuit and maybe see if that gets an improvement. See if maybe we can get it in the emitter of this TR1 here, or maybe inject it via this coil L21. Okay, so this socket here, this goes through an external aerial. It's a long wire. So what we're going to do is I'm going to put the radio back on its broadcast band again, and let's see if we can tune something in. I'll be very careful not to stick my finger on the mains down there. I should have made a cover for it.
Yes, you can see those in class over an academic year who will achieve and those who won't.
Okay, so we're getting a bit of signal into the radio there. We've tuned it into a station.
Can be taken to achieve success.
Christian Bright makes an interesting point. He says going to
Disconnect the aerial, it goes quiet as it should. So what I'm going to try and do now is I'm going to, well, we can just touch the normal input connector there, so let's just touch that.
thinking robot. Higher education in this society should be freely available to anyone that wants it.
Yeah. Anyway,
So we can hear that, that's our signal coming in. So what I'm going to try to do now is I'm trying to go to the input of this FET transistor. Let me see if we can get on there. Okay, so I'm on the gate of the FET there, and actually, maybe strangely enough, I'm not actually getting anything there, so that didn't seem to achieve very much. Let's try and see if we can get onto, I don't know, the emitter. It should be the same point, the emitter of this transistor. Well, that is actually louder.
Of 10 people in the Ballymurphy area of West Belfast during the Troubles.
There's that.
Including a priest who was helped by the army in 1970. The UK's full adult education information, home only.
So what I was trying to do there, I was actually just trying to bypass this FET at the front end by injecting the signal a little bit later on. So if I actually go to the emitter output,
I don't believe she may have been a victim of the serial killer.
I actually think that's a lot louder than
To Old Trafford for the first
that there. So I think that the FET transistor at the front end, I think this FET is damaged. Now this FET is, I think it's listed as a 2SK19. You can't actually buy them anymore, although you can get them on eBay. So I think the nearest I might have in stock to it is an MPF 102. So I think all I can really do is I'm going to take this transistor out, this FET, and I'm going to try and replace it with an MPF 102 and see if that makes a difference. Hopefully it will. Okay, well we've gone ahead and we've removed our FET transistor. I'm going to go ahead and give it a test with this Peak Atlas component analyzer. I'm not very hopeful that this will test anyway, because RF transistors, especially RF FETs, they always seem to test a little bit oddly. Okay, so it's coming up no component detected. Okay, so we've gone ahead and we've got that transistor, and let's connect our external aerial back up and let's see if we can hear anything. Hopefully we should get more than the 3 or 4 channels we got last time, if it was in fact that front end RF FET that had blown up. Only one way to find out though, isn't there? Okay, there's one station. Don't think we had that before.
It just might take me a bit longer to learn about it.
2 stations.
Have you ever wondered whether you're actually watch this space inside the 6 o'clock kickoff against? So how?
So basically we're picking up a lot of broadcast stations. Let's go to that other band we tried before. Okay, so basically it's picking up very, very lively now. It's bringing lots of stations in. So really not much more to say about that. That was a very quick and simple and easy repair. Simply all we've done is we've just replaced the front end FET. So if you've got a radio that's got one of these FET transistors in its front end and it's very, very deaf, it's more than likely that that's the problem. It's very, very common for those to blow up. So what you should do is, if you've got that problem, change the FET out, use something like an MPF 102 as I've done today, and you'll probably be fine. So that was it for today. Thanks very much for watching, and hope to see you again very soon. Until then, bye bye for now.